Yes, you chose to click on this video. First of all, congratulations. A great decision. But have you ever wondered if there's a universe somewhere out there where, instead of clicking on this video, you clicked on the one above, below, or beside it, or perhaps even closed the tab and left YouTube entirely? In this video, I won't just claim that such a universe exists. I'll also argue that it was created the moment you clicked on this video. Welcome to the fascinating world of quantum physics. You've likely heard of the famous double-slit experiment. For those unfamiliar, I'll explain it in simple terms. If you already know it, feel free to skip ahead using the timestamps in the video. Imagine we have a gray wall and place an opaque wall in front of it with two very small, closely spaced slits. On the other side, we have a device capable of firing tiny particles or bullets aimed at the slits. Now, in the normal macroscopic world that we're familiar with, if you shoot small marbles at these slits, what kind of pattern would you expect on the gray wall? Likely two straight lines corresponding to the two slits, right? One set of marbles would pass through one slit, forming one line, and another set would pass through the other, forming a second line. This is indeed what you'd observe in such an experiment with marbles. But what happens if, instead of marbles, we send water waves through the slits? Again, we're still in the macroscopic world, no quantum effects yet. If water waves pass through the slits, they start interacting on the other side. When two wave peaks meet, they form a larger peak. When two trows meet, they form a deeper trough. If a peak and a trough meet, they cancel each other out. On the gray wall, you'd see an interference pattern, alternating light and dark bands corresponding to constructive and destructive interference. This is a simple, logical phenomenon. But now, let's move into the quantum world, and I promise your mind will be blown. What if we fired electrons, quantum particles, at the slits instead of marbles or waves? Let's start simple. Imagine there's only one slit. If electrons are shot through a single slit, what kind of pattern would we expect? Like the marbles, we'd expect a single line. Indeed, if you conduct the experiment with electrons in a single slit, that's exactly what you observe, a single line on the wall. Now, what if there are two slits? Intuitively, you might think two lines would appear, as with marbles. But no, electrons, even though they are particles, create an interference pattern on the wall, just like waves. They behave as if they are waves passing through both slits simultaneously and interfering with themselves. You might argue, let's fire the electrons one at a time. Surely, they'll form two lines then. But no. Even when electrons are fired individually, over time, they still form an interference pattern on the wall. This suggests that each electron somehow splits into two, interferes with itself, and behaves as a wave. Here's where things get even weirder. Suppose we set up a camera or detector to observe which slit each electron passes through. Our goal is to figure out whether the electron is splitting or interfering with itself. Surprisingly, as soon as we observe the electrons, the interference pattern disappears. Instead, we see two distinct lines on the wall, as if the electrons are aware of being watched and suddenly decide to behave like particles. This phenomenon is known as the measurement problem in quantum physics. Observation, simply trying to measure or detect the electrons, seemingly alters their behavior. This shocking realization revolutionized our understanding of quantum mechanics. Now let's address the concept of parallel universes. One explanation for the measurement problem comes from the many worlds interpretation of quantum mechanics proposed by Hugh Everett in 1957. According to this interpretation, each time a quantum measurement is made, the universe splits into multiple parallel universes, one for each possible outcome. For example, in the double-slit experiment, the moment you observe the electron, the universe splits into two. One where the electron passes through the left slit and another where it passes through the right slit. You exist in one of these universes, observing one outcome, but both outcomes are equally real in their respective universes. The many worlds interpretation suggests that every quantum event creates countless parallel universes, branching out endlessly. It's not just theoretical. Mathematically, this interpretation aligns closely with the equations of quantum mechanics. Thank you for watching this far. If this video gave you a new perspective, don't forget to like and share it. We hope you're in a universe where you've chosen to support us. See you in the next video.